All right, let's play detective for a minute. We're going to crack a case that shows up on your doorstep or in your inbox every single month, disguised as your electricity bill. It's time to gather the clues.
So you open up that bill, you scan past the logos and the due dates, and then you see it. Those three little letters, KWH. You know they're important, you know they're the reason you're paying what you're paying, but what is a kilowatt hour really? Well, that's a code we're cracking today. For good.
Okay, so before we can understand the whole picture, we've got to lay the foundation. You can't solve the mystery without knowing the key players, right? And in this story, it all starts with two really basic, fundamental concepts: energy and work.
Let's start with energy. The simplest way to think about it? It's the potential to do something. It's the get up and go that's stored away. Think of it like the fuel in your car's tank or the charge in your phone's battery. It's not doing anything yet, but it has the capacity to make something happen.
Visit youtube.com/avidsystem and don't forget to subscribe.
And when that something actually happens, that's what we call work. Work is the result of putting that energy to use. It's the action itself. When electricity flows through a filament and a light bulb actually glows, yep, that's work being done.
And this is maybe the best way to picture it. Just imagine a heavy box on the floor. The strength you have in your muscles, just sitting there, ready to go, that's your energy. The moment you actually bend down, grab that box, and lift it, that action, that is work. So energy is the can-do, and work is the just did it.
All right, so we've got energy, the potential, and work, the action. But there's a really important piece of the puzzle missing. It's not just about if you use the energy, but how fast you use it. And that brings us to our third character in this little drama, power. So what is power? It's simply the rate at which you're using energy. It's all about speed. It's not the total amount of energy you have, but how quickly you're burning through it. You know, a fire hose spraying water has incredible power. A leaky faucet, drip, 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 has very low power. It's the same water, just coming out at a totally different speed. And this chart here just lays it all out, nice and simple. You've got energy, that's the total amount of stuff measured in joules. And then you've got power, that's the rate or the speed measured in watts. In fact, a watt is literally defined as 1 joule of energy being used every single second. It's a measure of flow.
So where have you seen this before? Oh, just on pretty much every single electronic device you own. That wattage number, you know, a 60-watt bulb, a 1500-watt hairdryer, that's its power rating. It's literally telling you how fast that thing chugs electricity to get its job done.
Okay, the stage is set. We've met our characters, energy, work, and power. We've gathered all the clues. Now it's time for the big reveal. Let's put these pieces together and finally solve this kilowatt-hour mystery.
And here's the absolute key to the whole thing. Your utility company, they don't actually bill you for power. They don't care how fast you were using electricity at any one moment. What they care about is the grand total, the amount of energy you used over the whole month. They're billing you for the total quantity, not the speed. And that is where the kilowatt hour comes in. The most important thing to remember is that it's a unit of energy, not power. Let's just break down the name, it's all right there. Kilo means 1,000. Watt is our unit of power, and hour is, well, it's an hour of time. Put it together, and a kilowatt hour is just the total energy you use if you run a 1,000-watt device for 1 full hour. Simple as that.
And the cool thing is, you can figure this out for literally anything in your house. It's like a super simple recipe. Step 1, find the wattage on your appliance. Step 2, divide that number by 1,000 to turn it into kilowatts. And step 3, multiply that by how many hours you use it. Boom, you just calculated its energy consumption in kilowatt hours.
So what does 1 kilowatt hour actually look like? Let's make it real. Picture one of those classic old-school 100-watt incandescent light bulbs. If you leave that single bulb on for 10 hours straight, you've just used exactly 1 kilowatt hour of energy. That's it. That's the amount your utility company is tracking. Okay, so mystery solved. We know what a kilowatt hour is. But so what? What does this actually mean for you, for your home, and, let's be honest, for your wallet? Let's bring this all back to that piece of paper you get in the mail. And wow, this chart really shows you everything. Look at the difference here, all in just 1 hour. That tiny little 10-watt LED bulb, it barely uses any energy. Your TV is a little thirstier, but look at that space heater, a whopping 1,500 watts. In just 1 hour, it guzzles down 1.5 kilowatt hours. It's a total energy monster because its power rating is just so darn high.
So let's just hammer this home one last time, because it's the whole point. Think of power. The kilowatts is telling you how thirsty an appliance is. It's a measure of its potential to drink energy. But energy, the kilowatt hours, that tells you how much it actually drank over time.
And if you remember one thing from all of this, let it be this. It's not just the power of your devices that costs you money. It's the total energy they consume over time. I mean, a super powerful blender you use for 30 seconds might cost you way less than a tiny little charger you leave plugged in all day, every day. It's always about power multiplied by time.
So there you have it. The code is cracked. You're now armed with the knowledge to read your bill and understand exactly what's going on. So my question to you is this. Now that you know the difference, now that you know how to figure it out, what's the first appliance in your home you're curious about? Go have a look. You might be surprised.
Thanks for watching.